Now sometimes we're just given a pair of coordinates and we need to use the equation that we've just tried. So, oh dear, I've written that wrong. So the gradient is y2 minus y1 over x2 minus x1. Now the trick with this question is figuring out which is which, because there's one way of doing it that's easier. Now it will actually work either way, but you're more likely to make a mistake if you get it the wrong way around. Now what I suggest is that the coordinate's got the lowest x value. Now -3 is lower than 2. Or the other way of thinking about it, if we were to draw it on a graph, this coordinate would be to the left of this one. Now, in any way you want to think about it, so the one with the lowest x value, we're going to call that x1, y1. So this will be x2, y2. Now you'll see in a second why I think that's a good idea. So, y2 is 10, minus 5, because that was y1. Now x2 was 2, minus 3. Now let's work that out. Again, directed numbers come into it. Now the important thing though is if you follow my suggestion here and always make the left hand coordinate the x1, y1, what happens is that the bottom line of your equation will never be negative. So only the top line will be negative if the gradient is negative, and it just simplifies your calculation slightly. So in this case the gradient is 15 over 5, and that simplifies to 3. Now finding the y-intercept, we're starting pretty simple with this, but there's two ways you can do it. So if you've got an equation, so y equals 2x plus 5, look, how you find the y-intercept is pretty easy. From the rule, or from the equation, this is our y-intercept here. Now, where you will find this if you see a graph of it is just literally where it crosses the y-axis. So all you need to do is look here, and you'll see that that point would be at y equals 5, and so your y-intercept is 5. Now sometimes you will get an equation that's not in the standard form, and so it's not as easy to see. Now you don't always want to rearrange them into the standard form, it's not always necessary. So to quickly find the y-intercept, what you just need to remember here is that on the x-axis at this point here, this is at, well, the origin is 0, 0, so when x is 0 and y is 0. So the y-axis, that line, is the same as the line where x equals 0. So we can always find the y-intercept by substituting x equals 0 into any equation. Let's do that. So 3 times 0 plus 4y equals 12. Now mathematically this is always a pretty easy thing to do because the x's all just cancel. 3 zeros are 0. So we're left with 4y equaling 12. Now that's pretty easy to solve. Divide everything by 4, y equals 3. Now just in case you don't believe me, we could transpose this equation over here into the standard form and see what we get. 3x plus 4y equals 12. I'll take my x's over the other side, and remember I'm going to put them in front of the numbers. Then I'm going to divide everything by 4. I'm going to write my gradient as a fraction in front of the x, plus 3. Okay, and so you can see here again that my y-intercept is 3, which is the same thing we calculated earlier. Now a couple of special cases for lines, vertical and horizontal lines. Now I've mentioned these before in this video, but it's worthwhile coming back to them again. This is something that you will come across a lot in Year 11 and Year 12 maths of pretty much any type, so it's good to be familiar with these. Now let's start off with the green line here. So this is a vertical line. What we've got to think about here is what number is constant here. So if we look at our x-axis, this point here is where x equals 2. Now basically for any point along that line the x value would be 2. So the equation of that line is x equals 2. Now x equals C lines, so x equaling any number, are vertical. Now they have, remember we've talked about gradient being a property of lines. Well, the gradient of these lines is undefined. It's not actually something that there is a number for, because if you think about it, gradient is rise over run. Now the rise is infinite and the run is 0, and you can't divide anything by 0. So there's no defined number for the gradient of a vertical line. Now with the blue line, what we've got to think about is where this is crossing the axes. Now it's crossing the axes at y equals 1. At any point along this line, y equals 1. So a horizontal line like that is y equals 1. Now if you get lines of that form, so y equals a number, they are horizontal, and the gradient of these lines, well, if you think about the gradient for these, gradient is rise over run. Now it doesn't matter how far you go across or what your run is, the gradient is 0, so you're not going up or down by any amount. And 0 multiplied or divided by anything is still 0, so the gradient for horizontal lines does have a value, and it is 0. Okay, that should be sufficient for you to go on with the next set of exercises.